Yeah, welcome to the talk on strategic domain-driven refactorings, or so I thought when I submitted this session to the conference. And you can see, well, it became something even bigger than that. It became a domain-driven transformation. And I will talk about strategic domain-driven refactorings, but in the bigger context of domain-driven transformation. And yeah, now I hope my clicker is waking up. Good afternoon. My name is Henning, and I am known as the guy with the many kids in the community. And so talking about stories from my private life, I do have 6 kids, as you can see here, and they have 3 different mothers. So thank you. Thank you. Thank you. So, actually, they only have one father, yeah. Well, as you can see, I'm used to operate in complex situations. And that's what we're going to talk about today as well, complex situations. I work as a coder, coach, and consultant at a company that's called WPS. We have a booth here right around the corner. So if you want to chat afterwards with me, I will be here until the end of the conference, hanging around at that booth. I'm also an author, domain storytelling. Marco, you mentioned that already. And there's an upcoming book, Domain-Driven Transformation, on the topic that we are going to talk about today. And storytelling, I like to start with a little story, not about my private life. We don't have enough time for that. Where's the story best told? Of course, around a campfire. So please gather with me around this virtual campfire here. And hear the story of Alphorn Auto Leasing. Alphorn Auto Leasing, what's that? Well, they are a company that does auto leasing, car leasing, obviously. What's auto leasing? Well, when you don't have enough money in your pocket, but you still want to have a car, then leasing might be the right thing for you. There are some leasing experts here in the auditorium as well. So classically, you give a lot of money to a car manufacturer, and then that car manufacturer will give you a new shiny car. But if you don't have enough money, then there's the leasing company, Alphorn, in our case, here coming in the middle. And now Alphorn gives a lot of money to the car manufacturer. The car manufacturer gives the customer a car. And the customer makes a monthly payment, a so-called installment, to our Alphorn, our leasing company here. And I think we all can imagine that there's a big piece of legacy software in place, which is obviously called monolith. Or monolith A. Okay, monolith is a tool that's not for the customers directly, but it's used by the Alphorn people. You can see a C4 style context diagram here, so we can see, where is it? Our customer here, the customer interacts with the salesperson, and the salesperson uses monolith, and also there's another guy called the risk manager. They also use this monolith system. Okay, you want to take pictures? Then I'll wait. This is monolith, and Alphorn's boss says, well, we have this old system, it's 25 years old. People on conferences tell me this has to be modernized, so dear IT people, go on and modernize it. And Alphorn's clever, because they don't do it on their own. They hire a smart consultant here. And the consultant tells them, well, before we start with the modernization, before we start with curing the patient here, we have to see first what are the diseases, or what is the disease that our patient has. So the first question is, find out what's actually the problem with our system here. Because different diseases require different treatment, right? And typical diseases that we find in legacy systems are, it's a big ball of mud. You might have heard about that, right? It has an anemic domain model. It has a bad team organization. Or typically, it has a combination of these diseases. And the good thing is there are cures for all these diseases and also for the combination of these diseases. And talking about this domain-driven transformation thing, there's what we call strategic transformation. Can we see that here? Yeah, strategic transformation and tactical transformation and socio-technical transformation. And these different parts of this whole domain-driven transformation is supported by different refactorings that we can use here. So there is a group of strategic refactorings. Those are more bigger refactorings. And there's socio-technical refactorings. Well, you don't refactor the system, you refactor the team organization there. And then there's tactical refactorings. And the tactical, they are split up into anti-anemia refactorings and anti-big ball of mud refactorings. And there's a connection. So these anti-big ball of mud tactical refactorings, those are the building blocks from which we build the strategic refactorings. Because we want to do something big, then we have to build it out of smaller things here. Okay, those are our domain-driven refactorings. I've started a couple of years ago a catalog collection of refactorings. You can find them on my website here. schwentner.io/domain-driven refactorings. I'm not sure if that's really a good URL. If you don't understand German, then maybe that's a strange name. Okay, there you can find this catalog. We don't have the time to look into the whole catalog, of course, and we also don't have the time to look into the socio-technical part and not into the tactical part. We have to focus on the strategic part, which is a pity, but it's already a lot of stuff for 50 minutes or so that we have here. And you see here the rows as a symbol for the monolith, because it's something thorny of which something beautiful can grow out. That's what we want to do with the monolith. We don't want to say, well, we hate this old piece of crap. We want to say, well, there's a treasure hidden in this thing, and we want to dig that treasure out. That's the kind of thinking that we want to have when working with legacy software. That's why it's called legacy software, because it's a legacy, something that our forefathers give us. Here, son. Here, son. This is this big piece of legacy software, and well, and now, now go on. Well, so strategic transformation. There is typically 4 steps to be taken here when doing strategic transformation. The first step is put the crap aside and rediscover the domain. Focus on the domain again. And with this knowledge about the domain, do the second step, that is modeling the to-be architecture. Model the architecture that you would do when you would start in the green field today. You're not starting on the green field, you are in the brown field, I know, but we have to think about how would it be without the ugly solution that we already have. How would we build the software today? Then the third step is taking out the big ball of mud and seeing, well, how bad is it really? And the fourth step is then do the move. So we start with creating a to-be context map, and then we put that together with our big ball of mud, and then we do this magic arrow here. Well, and of course, in this magic arrow, well, it will take some time to do that. So when we take these 4 steps, when we are doing strategic transformation, then it's important to understand that the key to this modernization is controlling the complexity. That's what we're doing with software development in general, and especially with DDD. So there's a quote by Brian Strausstrup, the maker of C++. So somebody who knows about complexity. Some C++ hackers here? No, a few hands, okay. So that's why I don't give any laughs. Well, yeah. Okay, so Brian said, well, the most fundamental problem in software development is complexity. And then there's a fitting quote from Brian Kernighan: controlling complexity is the essence of computer programming. And then there's, of course, Eric with his blue book, subtitle, Tackling Complexity in the Heart of Software, right? And then again, Brian, who says there's only one basic way of dealing with complexity, and that is divide and conquer. So we have to split the complexity up to manage it somehow. And that's what DDD does. It gives us different tools to tackle complexity by splitting it up. On a strategic level, that is subdomain, that is bounded context, context mapping. Those are things to divide this complexity up and conquer that complexity. So what's the problem with complexity? When we look at the typical domain that we want to build software for, well, then it is huge and it is complex, and typically it is bigger than our brain. And as we all know, to build software for that domain, we have to understand that domain. And well, we can't understand it as a whole, and well, that's a problem. Of course, you know, this is a developer's brain, and developers have the biggest brains on earth. We all know that. Still, even our brains are limited, and we cannot wrap our head around the whole domain at once. And that spawns several problems. So the typical domain is too big to be understood as a whole. And there are two kinds of problem classes here. The first class is the so-called whack-a-mole issues, and the second class is the Max and Morris problems. Whack-a-mole issues, you might know this game here, whack-a-mole. There's a wooden board with holes in it, and you get a hammer in your hand, and then a mole comes out of a hole, and you have to hit him on the head, and then he comes out of the other hole, and they come quicker and quicker, and you have to hit quicker and quicker, and you cannot win that game. It's like Tetris. It's just quicker and quicker and quicker. And that's a bit like a big old software system. Because it's so big, you get a user story or another requirement, and you make a change to that system, a small change here, and then somewhere up there something breaks, right? That's the mole coming out of the hole. And then you fix that problem here, and then something breaks there. And when you fix that, and when you're lucky, it stops. But, and that's the important point, it only stops because you're lucky, not, not because you knew in the first place you weren't breaking anything. And this problem, of course, gets bigger the system gets. That's the reason why it is so much more fun to work with a new project, because it's small. And the probability that you break anything by making something new is relatively small. And then 5 years, 10 years, 20 years, the system grows and grows, and well, it's not so much fun anymore. Who works on an old piece of software? Many hands. Who has a lot of fun with that? At least some hands. Yeah, there are different kinds of fun. This is a special kind of fun. Well, so whack-a-mole issues. One problem why big systems are, well, have issues. And the other problem class is what we call the Max and Morris problems. Max and Moritz in German, that's an early German comic strip, something like that. And maybe you know that even outside of Germany, Max and Moritz are two naughty boys. And these naughty boys, they play tricks on the adults. And the first strike is that they go to the chicken of the widow Bolte, an old lady, and they bring a loaf of bread, and then they tear this bread into pieces, and they tie together these pieces of bread with a thread. And you can see that here on picture number 1. They leave these small pieces of bread for the chicken, and then the chicken come and eat that bread. And you can see here, well, now these chicken are tied together, connected well, and then they try to run into different directions, and eventually they fly up, and well, then they hang themselves in the apple tree. jedes legt noch schnell ein Ei und dann kommt der Tod herbei. That's a tough one to translate. Okay, so this is a kind of a strangler pattern that is this is a kind of a strangler pattern that's not what we want to do, right? And when we think about these chicken, well, this is those chicken are the different teams that work on our one big monolithic piece of software. Because the software is connected, interconnected, the teams also cannot move independently. The teams, they feel like this here, right? When I go into this direction, I always pull on other teams and they are like, what's happening here? Talking about special fun again. So Max and Morris problems show this team problem. The solution for that is this socio-technical transformation also. So we see different problems classes come out of this complexity. So we want to deal with it. And how can we deal with that? How can we modernize our IT infrastructure with this old big piece of software? And there are basically two ways that we can choose. That's replace or transform or a mix of the two. So the classic way of replacement is to say, well, we start with the old system. This is an old system, and those are our users. And then beside that old system, we start building a new system. And then it grows and grows and grows, and eventually the new system is done. Eventually the new system is done. And then we just flip the lever, and the users, well, they now use the new system, and we switch off the old system, and we're done. Okay, so, well, this is the idea, just flipping the lever. This is also called a Big Bang replacement, because like with the Big Bang, a new universe is there. We flip the lever, and then there's the new universe, the new system. I like that name Big Bang because it describes what is going to happen. There will be a Big Bang, of course. So actually, I wouldn't recommend to go this way. I mean, for us consultants, it's good if people choose that way because finally, at this point, that's when we are called. But to be honest, don't do it. Start with the old system, yes, but maybe it's a better idea to start with something small new here. And you can see the users, they are already using the small thing as well. So now the users have two systems, which is also not nice. But we feel the pain earlier, and that's good. The earlier we feel the pain, the earlier we can do something against it. That's the idea of agile in the end. We want to feel the pain early, so we can react on that. So, and then we grow the new system, and grow it, and maybe at some point in the future, the old system will be gone, or maybe not. Maybe we will stay in this phase for a long time, and that's also okay, because we have two systems which help us do our work. But maybe we can switch off the old system eventually, and then we only have the new system here as well. And building the new system, that can mean, well, we build something new, or we cut something else, we carve something out of the old system. That's the transformation part, when we transform the old system into the new system, so that means the old system becomes the new system. And this is also called a strangler fig application, that's this pattern here. There we have the strangler pattern. It's called strangler fig application after this strange tree in the rainforest, a strangler fig. And what is that? Well, when we look into the rainforest or generally in the forest, for the plants is all about the light. So the best place is on the top where you can exhibit your leaves directly to the sunlight, because there you get the most energy and you can grow the fastest, of course. The problem is for small trees, well, they have to start from the bottom and then grow up, be big like the big trees. Well, that's not smart. The strangler fig, well, it's a bit smarter. It says, well, I don't want to start at the bottom, I want to start at the top. That's why it starts on the branches of so-called host trees. So it has its leaves already in the direct sunlight, and then it grows a root to the bottom, and then it grows and grows, and you can see here wraps itself around the host tree, and eventually the host tree is strangled. That's why it's called a strangler fig, because it's a fig tree. Sorry. Because it's a fig tree that strangles its host tree. And this is a bit like the old software system and the new software system. The new software system, they live side by side, and then eventually maybe the old system dies. So and there's a lesson here, and that is, of course, strangler fig application is better than Big Bang replacement. And maybe that's a bit coarse-grained when we look into the details, when we see what we want to do with DDD, with strategic design is bounded context. Sorry. I talked to Shin 2 hours ago. Maybe she has my voice now. Okay, so when we talk about DDD, we want this idea of more modular systems, and when we have a more modular system of bounded context, then we can answer this question: do we replace it? Do we transform it? We can answer that on a more fine-grained level. We can say, well, these two parts here, we want to carve them out of the old system, so we transform these parts of the old system into the new system. And here we build something new, because that's in such a bad state in the old system, we cannot transform that. And here we build a standard component, which wasn't there when we built the monolith 20 years ago, but now we have the standard component. And be careful, these are all verticals from above. So we want vertical slicing here. Okay, so now to the domain-driven transformation and these 4 steps that we have here. The first step is domain rediscovery. That means we want to understand, maybe understand again, what is happening in the domain. So we want to put aside the solution that we have and focus on the problem again. So we have to put the monolith to the side, and then Gesundheit. We have to put the monolith aside and move from the brown field at least into a green field in our mind, and ask ourselves the question, well, with the knowledge that we have now, what would be the goal architecture? And that means we have to do a mindset switch. We developers have to move on from thinking about technology to thinking about business. So we move on from being just technical people to being business enabling people. So we don't think about the tooth wheels anymore. We still think about them, but not only about them, we also think about the dollars. What our users, our business experts are doing. That's probably on a DDD conference not such a surprise, right? On other conferences, when I show the slides, people say, ah. Okay, so we want to move on to thinking about the business. And what cannot help us there? Of course, collaborative modeling. Collaborative modeling is this idea of bringing the people together that belong together, people from the domain that have the knowledge, and people from our side, from software development, that want this knowledge, and model together, build the domain model together. So methods like event storming, like domain storytelling, and so on. And with these methods, we dig into the domain, we understand the process or the processes of our domain. We want to know what's happening. So in our case, in car leasing, we have a first idea of what car leasing is, but we need to know more. So we invite the right people to a session. We've already seen this C4 diagram. We see there's a customer, there's a risk manager, there's a salesperson. We invite these people to a session and we interview them and we let them tell their story. And then we hear, well, it starts with the customer. It starts with the customer who tells their wish for a car to the salesperson. The salesperson will then calculate the installment for the contract. And let's assume the customer can afford that installment. Then the customer will sign that contract. Now we have a signed contract. And this signed contract, the salesperson will pass on that signed contract to a risk manager. The risk manager tells us, well, I check the risk, and I do this by checking the credit rating and calculating the resale value. And then based off this credit rating and the resale value, I will vote the contract. To vote means say, yes, we want to do this contract, or no, this contract has too high a risk, we cannot do that. Let's assume the risk manager votes positively, then the salesperson will give the car to the customer. So what you can see here, that's the domain story, one possibility of collaborative modeling, of understanding your domain. Other possibilities exist as well. Now with this understanding of the domain, with this language of the domain that we learned, we can move on. And what's interesting, when you look into the words here, we do not talk about computers, right? There is no monolith or anything in this. There's only leasing words here, and that's good. That's this moving on the green field again, focusing on the problem again, putting the solution aside. Because when we model the process with the solution as it is today, yeah, well, then we model the solution as it is today. And we want to move on from that solution. For that, we have to understand what's happening in the business. Okay, if you want to know more about domain storytelling, then there's this book here. The second step is, now with this understanding of the domain, we want to determine our to-be architecture. We want to know how should our new system look like. And the next thing to do here is drawing boundaries into our understanding, because we want to see the subdomains. We want modules in the end, right? So when we do it with domain stories, then it's a good idea to stay in this scope. Who has done domain storytelling before and has heard the word scope? Some hands? Okay. The idea of scope is that we say, well, a domain story has a certain scope. For example, we see, is it coarse-grained? Only the important stuff, the big stuff? Or is it fine-grained? Do we look at all to the details? Is it as is, or is it to be? And is it pure, or is it with IT systems? And here for domain splitting, coarse-grained domain stories is the way to go. To be stories, optimized stories, we want to look at an optimized story, process here, is the way to go. And pure stories. We don't want to see IT systems here. And with these stories, we ask the question, from the view, from the perspective of the actors, which activities belong together. And we work on that together with our domain experts. And here in the leasing company, they tell us, well, the steps 1, 2, 3, and 8, they form a subdomain. They will not use the word subdomain. That's tech speak. But for us, it's important that they form a part of the domain that belongs together. And this subdomain is called sales here. And then we have another subdomain that's down there with the steps 5, 6, and 7, which is called risk assessment. So 2 different areas of our domain that we have here. And from these subdomains, we as DDD people know that, well, we will derive bounded context. We will derive modules in our software. At least that is what we would do when we were on the green field. We aren't on the green field, so let's see what we do here. But first, this is the way to go. We take the subdomains out of this, we take the context out of this, and make another diagram, which is called a context map, obviously. And you can see here for the slides, this contains only 2 subdomains. In real life, typically we will have more than 2 subdomains, more bounded context. Also, it's typical that we will have more than one story, we will have several stories, and we will bring all the context from all these stories together in one context map. Okay, so this is the goal architecture. These are the modules that we want to have. We don't want to have the one big module, the one big monolith. We want to have at least 2 modules here, 2 vertical modules here. Okay, now that we know where we want to go, let's see where is it that we are. Let's get out the monolith again. So let's look at monolith again, sorry. So we started with the context view. Let's look into the details here. Let's go into the container level, the next level of this C4 model. And we can see here, well, monolith is what we called a layered architecture, or has a layered architecture. There's a front end, a back end, and a database. And you can see this is an old system. There's some servlets and JSPs and EJB2. Oh, wow. And an IBM DB2 database. At least it's not EJB1, right? So, okay, so we have a layered architecture, and that is actually something good. At least we have that. So we have a horizontal cut here. When we go deeper into these layers, we see there are components inside of these layers. So there's a leasing servlet and a partner servlet up there. Maybe I should do it like this. Here there's a leasing servlet and a partner servlet. So again, Java technology. And then in the back end, we have a calculator and a contract service, other things. And there's a contracts database table and a partners database table. What I like about this architecture is that we see at least some domain language here. Right? Partner and contracts, those are words that come from the domain. That's better than names like CTX, right? Who works on a system with names like CTX here? Okay. And the others, you all have real domain names, that's great. That's good to hear. Or you're just too tired to raise your hand, right? Okay, so at least some domain knowledge is something that we can see here in this architecture. And what we have is also horizontal layering. What we do not have is vertical structuring, right? We do not have lines from the top to the bottom here. So we have what is called, in general, a big ball of mud. Because there's no vertical structuring, everything is connected to everything. Sales and risk assessment, we cannot find these different parts in the system. And how can we now put these 2 things together? The as-is architecture that we can see here, and this idea of, well, we want to have sales and risk assessment and maybe other contexts as well. Well, let's focus on the back end first, because that's hard enough, and see where would we draw the boundaries here inside? Well, the sales, that happens here. So sales use the calculator and the contract service, and the contract and the partner. And where's the risk assessment happening? Well, it uses the partner service and the contract service and the contract and the partner. How can we split that up, right? Okay, let's start with the easy parts. Well, calculator and partner service, we can tell those apart, but what about the rest here? What can we do with that? Well, the first idea is to say, well, let's duplicate that stuff so we can pull these things out of each other. So then we have a calculator here, contract service, contract partner, and again, a partner and a contract on the other side. And of course, this looks like there's a lot of duplication going on here, right? And that might be bad. this duplication. Do we really have a lot of duplication here? To answer that question, it's not enough to stay on this level. We actually have to go even deeper. So let's look at the classes, contract service, and contract here. So let's see how we find our sales context and risk assessment context in these classes here. So we have to go on a level where we look at methods and even fields here. I only put the methods on the slide because the fields didn't fit anymore. So what we can see here is that monolith is not only a big ball of mud, it also has an anemic domain model because all the domain logic is in services. You can see that here, sign contract and vote contract. That's the domain logic. You remember from the domain story, that's something that our users are doing. The customers are signing contracts. The risk managers, they are voting contracts. And then we have a contract, which looks like a domain object in the first place, but well, there's only getters and setters there. It's only a big data bag in the end. Typical anemic domain model. So we can't do anything about the anemia now. We have to deal with the big ball of mud first, but maybe we will do that later. Okay, so let's try to find our contexts inside here. So when we think about sales, when we think about what we found in the domain story in sales, then we will see, well, we need a class contract service, and we need this logic for signing a contract. We don't need the logic for voting a contract. And we need a contract with a contract number and a signature date. We don't need the credit rating and the voting result. And on the other hand, for the risk assessment, we need some other stuff. We also need a contract service with this vote contract logic. And we again want a contract number and then the credit rating and the voting result. And you see, well, it looks like pretty much a mess, right? That we see here. So let's try to pull this out of each other again. So, well, this is the duplication that we were fearing of. If we now delete everything that's not needed on these both sides, then we see, well, it's not so much duplication that we were expecting in the first place, right? So, of course, we have this contract number here and there. That is kind of duplication. That's the identity of our contract. We need that to be sure when we talk in this bounded context about the contracts that we mean. The same like when we talk in that bounded context about a contract, a leasing contract. So let's now clean that a bit up. Then we get a diagram that's something that we would build when we would start on the green field. That's where we want to go, right? And how can we get there? Well, that will take some time, to be honest. So a domain-driven transformation is never something that is done quickly. That's always something that takes a long time. And that is because the system that we are going to transform is old and is big. If it weren't big, well, we wouldn't have to transform it. So it's important to see, well, that's not something that happens in one sprint or a handful of sprints. That's an initiative that takes a long time, which also means we need some backup from the management and some money from them and so on. So there is some planning that we might have to do later. And to support that planning, it's a good idea to start with something what we call a transformation backlog, and that is see, well, what are the refactorings that I have to do to come to this here from my monolith software. And that's where the strategic refactorings and then the tactical refactorings come into place. So we need a refactoring, number one, extract the bounded context sales. And then refactoring number two, we need a refactoring, extract the context risk management, risk assessment. 2 sticky notes? Oh, well, it sounds easy. But of course it isn't. Bounded context is also a big thing. and it takes a long time to extract that. So that's why we need smaller steps here. So there will typically be these tactical refactorings as well, like 1.1, extract a specialized contract. Or to be more exact here, extract a specialized anemic entity contract here. And then we also want to extract a specialized contract service. And we will also probably extract a specialized data model here. And again, from these things, sometimes we want to move onto an even smaller basis and go into refactorings that talk about methods and fields here. So we start with something very big, but the cumbersome work that has to be done, well, those are small steps in the end. And they have to be done for a long time in parallel to new development that we're doing. Okay, so this is 1.1 and 1.2, the tactical refactorings, and the same is true here for this strategic refactoring number 2. We will do tactical refactorings here as well. Okay, and talking about refactorings, here's a small insertion about these domain-driven refactorings. Well, I told you there are 3 classes, or maybe even 4 classes: strategic, socio-technical, tactical. And the tactical, they are split up into against the model anemia and against the big ball of mud. And these are the 2 that we are looking onto today: the strategic and the anti-big ball of mud tactical refactorings. So the strategic domain-driven refactorings that are interesting today are extract a bounded context, and another one is implement a bounded context from scratch. That's this Strangler, Fig, or Big Bang on a much smaller scale, right? This making the decision, do I carve it out? Do I transform it? Do I buy something? Do I build something new on a bounded context level? And for us today, most interesting is, of course, extract the bounded context. And for that, we have some tactical domain-driven refactorings that will support it. And that is extract a specialized entity, extract a specialized anemic entity. Well, that depends on which diseases does our patient have, which is the refactoring to apply here. And it's also the question, what's the way to go first? If we have a big ball of mud with an anemic domain model, which disease do we heal first? The big ball of mud or the model anemia? And typically it's an intertwined thing to do. And then we have extract specialized service and data model. You see that here as well. Extract specialized data model, that's a database refactoring. Well, that's a different kind of animal, but it's also possible. So that's maybe the most important lesson that I want to give you. Don't give up. It is possible. Maybe in most cases. Okay, so those are the tactical domain-driven refactorings that support us in doing strategic stuff here. And when we go into the nitty-gritty details, then we see, well, refactorings, they are described in mechanics. And you see there are many small steps here. Those are the mechanics for the extract bounded context refactoring. Those are the small steps for the extract specialized anemic entity. Well, I'm not going to read them all to you now. But you can see it starts with very simple and small things like create empty new class in carved out context. Or here, sorry, in the extract bounded context. In step number 3, create an empty package or namespace or module, depending on your technology, for the to be carved out context besides the big ball of mud. Okay, this is the written mechanics. Let's look at them in a more visual way. If you want to read the stuff, you can find that on my website. We come to the next step. Let's do the move now. And there are several sub-steps. The first thing is that we have to talk about planning here. As I told you, it takes a long time. And that means beside our product backlog, which is our agile way to look onto our requirements, we now have this transformation backlog with the refactorings to be done. And every time when we plan a new sprint, then we can do basically two things. And one thing is we say, well, we reserve a certain part of our sprint capacity for the refactoring. Or we can even say we spend the whole sprint doing only refactoring. Actually, I'm more a fan of the first thing because, well, it takes a long time and we have to give our users some new stuff as well. So what I typically would do is something like this here. I go back, so when we plan the first sprint, then we do something like this. User story A and B, those are planned in the sprint. And also strategic refactoring number 1 and tactical refactoring 1.2 and 1.3. Where's tactical refactoring 1.1? Apparently it got lost. The management decided we ain't gonna do it. Okay, and when that sprint is done, well, the user stories are done and the tactical refactorings are done. The strategic refactoring, well, it's typically not done because strategic refactorings are so big, they are bigger than one sprint. That's one of the reasons why we have to split them up into tactical refactorings, because we need small steps that are small enough to build us or to transform our system into another viable state. That's what we want to have the whole time, a viable piece of software. Running code in production is what we want to have here. So the next thing then, of course, is, again, plan some stories here into the sprint backlog. And here we have the tactical refactoring 1.4. And then we do that sprint. And when that sprint is done, then also this strategic refactoring number 1 is done. Because when all the tactical refactorings are done, then this will be done. And then we move on, plan the next stuff, and so on. And maybe eventually the transformation is done. Or not. The point is, even if we stop in between because, well, of reasons, we say, well, we can't do the refactoring now anymore because there are so many new requirements and we have to put all this stuff into the system. Yeah, well, then we have at least started and later we move on with this. But of course, we need to be persistent here. We need to go again and again and again and see it will take a long time until we finally transform this stuff. And talking about the transformation means also we have to talk about the small stuff, the small transformations that have to be done here. Yes, it's called strategic domain-driven refactorings, but as we have seen, these strategic refactorings are made of tactical small refactorings here. So when we start with this big monolith here, with the big contract service class and the big anemic contract entity class here, then we start with small steps transforming that. So we start with the strategic refactoring, extract bounded context, risk management. Okay, before we do that, I should have rehearsed that part. So we have this big monolith here, and there's some piece of code which calls the method vote here, maybe from the UI layer, or we don't know yet. And the vote contract on itself uses this get contract number and uses credit rating and voting result. And when we now start the transformation, we start with the strategic refactoring, extract the bounded context risk assessment. And then we start with the first tactical refactoring, and that is extract specialized service, the contract service. So we start with building a new empty class contract service. Those are small steps, right? We can take them. And then the next thing would be to, well, move vote contract to this. And how do we do that? Well, we start with a copy of monolith contract service vote contract into risk assessment contract service vote contract. And then this means, well, vote contract in risk assessment will use these fields here, right? Because it's a copy of the other thing. And maybe then we can move on and say, well, vote contract, we delete the implementation, we keep only the signature, and the implementation is changed to just call vote contract in risk assessment. So now we've moved the logic from monolith to the new bounded context. And when we've done that, we can use, we can go through all the calling parts where we call the methods vote contract, monolith vote contract, and move them to risk assessment vote contract. And eventually we don't have any code that is calling vote contract anymore. And that's the point where we can get rid of that. And you can see those are all small steps. Step by step, we move the stuff over to the other side. So now we're done with this extract contract service tactical refactoring, which is nice, but as you can see, well, we have this connection here from the risk assessment bounded context into the monolith. That's, of course, not so beautiful. So the next thing to do is to say, well, let's extract the contract here. And again, we build an empty class, and the contract service will use that empty class, and then we copy the contract number here, and the logic of vote contract will now use that contract number, and then we will add the credit rating, and that will be used, and we will not use that in the monolith anymore, so we can delete that. And so we move on also with the voting result, and eventually all this stuff can be deleted from the monolith. And now we are in a state where we already have a first implementation of our shiny new small bounded context risk assessment here. Of course, there's probably a lot of more stuff to be moved, and we have only talked about the domain model so far. We have to do this for the data model as well, and we have to do this for the UI, and that's special work to be done as well, but we can see we can do it in small steps. And that's important, because only with these small steps we will be successful with it. Then we can delete that stuff from the monolith, and we can see the monolith is starting to shrink. And that's good, because the big ball of mud is then a not so big ball of mud anymore. And that's good. Because maybe we have to live with this thing for a long time. Maybe forever. And if it's smaller, then that's not so bad anymore. Okay. So this is the basic idea of strategic refactoring from the top to the bottom. And we still have this dynamic domain model here. So the next thing to do is, of course, the tactical design here. So look at the risk assessment and the model that we have inside here and see that this is dynamic. And then we can apply tactical patterns against model anemia. For example, push domain logic down. But sorry, we don't have the time. We don't have the time for that today. And what I want to give you in the last couple of minutes is an outlook. So I've shown you strategic refactorings, but you see this is only a part of the domain-driven transformation. There are other things that are also interesting. So tactical transformation, anti-anemia refactorings, that's something that you want to look at. And there's also this part of socio-technical transformation, so the accompanied team reorganization that has usually to be done together with the system. And then there's also something that we call technical transformation. That is, usually before you can start with all these measures, you have to stabilize your system in a technical way. So you have to raise your test coverage. You have to maybe bring your system into a state where it can be built in an automated way. So the metaphor is we have a patient that is sick, and before we make the operation, well, we have to stabilize that patient so he doesn't die when we do the operation. And that's what we want to do with the system as well. We don't want it to die. Okay, and then another point with the outlook, that's a look into the future. That's something that we are actually not sure about. That's something that we want to give for the discussion. So I want to plant an idea in your heads, and then I would be happy to hear afterwards what your ideas or what your thoughts about this idea is. And that is my colleague Carola. We started with this idea, and we have this idea of what we call domain categories, or maybe it's domain patterns. We don't know yet what the right name is. And that is, there are different kinds of domains, and for these different kinds of domains, you need different tooling. For example, there are pipeline domains. Pipeline domains are domains that are in the domain, the people are working on a piece of the domain, and when they are finished, when they have produced a result, they give it to the next person. And then the next person is working on that and giving that to the next one. We've seen this in the leasing. That's a pipeline domain, because it starts with the sales, and when the sales is done, they pass it on to the risk management. And risk management is done, they pass it on to object management, and maybe sometimes to special care. That's a pipeline domain. And pipeline domains, we find them in leasing here, but also in logistics and insurances and banks. And pipeline domains, well, they are relatively easy to split. And those are domains that can be easily understood with event storming, domain storytelling, tools like this. That's the reason why when you look at a conference here, probably most of the example domains that you see are pipeline domains. Because with these, we speakers can show, well, oh, our stuff is working, right? But I think there are other kinds of domains as well. For example, blackboard domains. I'm not sure if this name is good, but the idea is we have a blackboard or maybe a whiteboard where there's stuff on it, and then I take this stuff, I do something, and I put it back onto the blackboard, and then someone else takes this thing, does something, puts it back, and then I take it again. So there's not this pipelining, I'm done, and now somebody else is there. And this is, for example, in healthcare, where we find blackboard domains or event management, or what's interesting, what we are doing, software development, that's also a blackboard domain. That's the reason why the waterfall model is not working, one of the reasons. Because the waterfall, well, that works maybe for pipeline, but not for what we are doing, right? So pipeline domain, blackboard domain, and then there's a third kind of domain that's a dialogue domain, which is maybe a special case of the blackboard domain where two people or more people are exchanging information and negotiating over things here as well. Okay, with that idea planted into your head, this might be total BS. We're not sure about that. I'm not sorry if that was in the code of conduct. I will have to check with Annika afterwards. So maybe this may be total nonsense, or maybe this is the next great idea. We're not sure yet. I'm happy to hear your feedback about that. And with that, I come to the conclusion of the day, the talk. And that is, of course, in roughly an hour, I can show you only step 1 and maybe step 1A, 1B. And of course, when you do it in real life, then it's harder. But I think I gave you a first glimpse of how this can work, and not only on the big level, but also down to the bits and bytes, to the methods and fields that we want to split here as well. So if this is interesting for you, there's this upcoming book, Domain-Driven Transformation here. And maybe the most important point of the conclusion is this lesson here: monolith transformation is possible, and it's hard. So there are many mistakes to be made. And my recommendation is, don't do this mistake. Don't go on the journey alone. Don't make all the mistakes yourself. It's better to hire someone who already did all the mistakes. Thank you. Yeah, and talking about advertisement, I also want to make an advertisement for something good. Please consider making a blood donation, because after the pandemic, the blood banks are empty and our blood is needed. And you don't have to look there, and then it's not so tough. Yeah, and with that, thank you for your time.